All right, list the possible rational zeros. So that is the rational zero test, plus or minus all the factors of p over plus or minus all the factors of q. P is 4, q is 1. Well, I guess p is -4, but you do plus or minus anyway. And this is division. So there's part A. Those are the only rational numbers that are even possible to be zeros, the only possible x-intercepts. Part B, sketch the graph of f so that some of the possible zeros in part A can be disregarded. And then C, determine the rest of the real zeros. Okay, so if we go to our calculator and graph this, okay, so we've got a general shape of the graph. It looks like it goes through 2, but like a previous question, it could just be super close to 2, so we shouldn't assume that. Hit trace to enter to jump to that location. Looks like 2 is an exact 0. Also looks like -1, so trace -1 enter, jump to that. Looks good. And it looks like -2. -2. So -2, -1, and +2. So -2, -1, and +2. So what they're asking us to do then is confirm that all of these x-intercepts, 2, -1, and -2, are somewhere up here in this list. This list can have other stuff. Not all of these are zeros. This is only a third degree. There's no way it has that many zeros. But for the nice whole number, rational numbers, it has to be in that list. So +2 over +1 is in the list. -1 over +1 is in the list, and -2 over +1 is in the list. Part C, determine all the real zeros. So how many zeros should this have in the end? Because it's degree 3. So in this case, we have all 3, so we are finished. If there was some that we could not find because they were not nice whole numbers, they were somewhere decimal, we'd have to divide out one of these synthetically, divide out another one synthetically, divide out another one synthetically. You have to do that as many times as you need to get it down to quadratic. And then, of course, we can finish with the quadratic formula if nothing else. But for this one, all 3 of the zeros were easy to find from the graph.